Please, Andrea.
Okay, thank you for the introduction. So in effect, let's say it's 2.5 because because we share the talk, let's say, with Tijani. And so the work I'm going to talk about is work done by me, Tijani, Shahid, and Dania Korman, and we particular focus on the work of two students, Rosario Patané and Ayub, that were there, and now they are not there. So I will have to, maybe they are ashamed of this. And so I will mostly introduce some part of our, let's say, vision, to use this term, and then Tijani will go more into one of the technical parts. No, this is not good. So I will take the other version. Sorry. Okay, this, and then this. Okay. Full screen, full screen, full screen, full screen. This, okay. Okay, now it's good. Okay, first of all, what are the actors that we are going to talk about? Well, on the one side, we have users that want to consume services, or in other terms, applications. They can be entertainment like Netflix, YouTube. They can be more critical, like in the future, applications to support autonomous vehicles, and this kind of stuff. And in the middle, we have the network operator who is there to move bytes from services to users and back. And so this kind of communication is happening mostly with the paradigm of cloud computing. Okay, but I don't want to talk about this. Okay, what we want to now analyze is what are the benefits of edge computing, meaning moving the computation resources to the edge of the network so that these services can run directly in the edge of the network, very close to the users. And the advantage is that we have less latency because the services run very close. And so we can enable applications that now are not really possible, like augmented reality, virtual reality, maybe support for driving, etc., etc. And also we reduce upstream traffic. So we talk already. Professor Capone was talking more about edge for the network operators. I'm going to talk more about edge for users. Not to control the network, but for running third-party applications. So there are already big actors like Amazon that offer edge services, edge offers. They call themselves edge, but in effect, they are just closer clouds. So they are very close to the access network, but they don't deploy resources into the access network. Okay. And so the gains of edge computing are not really achieved with this model here, even if they call themselves edge. And to convince you that, in effect, what we have now is not edge computing, these are measurements from two cloud providers, including providers that have some deployment at what they call edge, but they're not inside the access network. And of course, the round trip time is much higher than what we will need for very low latency applications like augmented reality or virtual reality or autonomous driving. We will need to be here, while most of the time we have higher delays. So, so I don't have the slide from Professor Capone here, but why we cannot achieve very, very low delay? Well, it's because we have always to go out from the access network and reach the closer location of these service providers. What if we had the services running directly into the access network, directly in the first hop? So what we are looking at is this vision of edge computing where services are really in the access network, and in particular, I'm going opposite way, yes. And in particular here, in the central office, or even co-located with the base station, so where the DU is, as today we saw, or directly into the network internet boxes of users. And these paradigms have been called with different names, but we call them edge in general. So there are already solutions in which the service providers go into the access network of network operators. An example is Netflix Open Connect. They knock at the door of Orange or Telecom Italia or service network operators, and they come and install their hardware server. And so users can connect directly to these boxes of Netflix instead of going out from the access network. So this is good, but it is limited, because what if now there are 100 service providers, not only Netflix, that want to run at the access network? Shall we install 100 racks? Or what if some of these applications want to run directly in the base station? Do we have space for 150 hardware boxes? And every time we have to maintain some of them, we have to enter into the central office, so or into the in the location of the base station. So this solution, where there is only where each tenant installs their own hardware resources, doesn't scale. And so what we claim instead is that edge computing should be open to different service providers. And in this sense, the key of edge computing is in the network operator hand. So they are the ones who will already deploy resources for their own needs, as Professor Capone said, to control their own network. And so some of the resources will be reserved to network-related actions, but they could install opportunistically additional resources and rent them to third-party service providers at a relatively low marginal cost. So we suppose that this can happen if network operators have enough courage to invest in this, instead of letting Google and Amazon take their possible future market. And so we assume the network operator deploys computational resources around CPU, GPUs, and so they can virtualize them and share these resources with third-party service providers, Netflix, Google, or even a new actor that doesn't have the market power of Netflix, but can still profit from running very close to the users. And so in this context that we imagine, so we call this scenario multi-tenant edge computing, because there are multiple tenants that can run close to the users. And in this scenario, one problem emerges. So if I have resources, how can I share them between multiple service providers? And so, of course, if the network operator deploys the resources, it wants to maximize his own utility, his own objective. And we assume this objective could be minimize upstream traffic or improve the quality of experience of their users, so reduce the latency or control the jitter, or maximize revenues in case it gives these resources with a price to the users. And so this resource partitioning between several service providers, in order to maximize these objectives, is challenging because we assume that service providers are isolated. Netflix doesn't want that Google can see what is their traffic, and doesn't want even that Orange sees what is the traffic. So everything is encrypted, and the network operator cannot know what are the content or the actions that the users want to perform. And so the network operator has to take decisions a bit in the dark, just by based these decisions on observed measurements. And another challenge is that resources are limited, not as in the cloud. So if I give resources to the blue service provider, I have to remove to the yellow service provider. So we cannot inherit the strategies from the cloud service sharing. And so the general context is this one, where I took the slide from the thesis defense of Ayub Benamar. And so we have users, we have service providers having a slice of resources at the edge, and the network operator wants to dynamically change this slice, this partitioning, the resource allocation, in order to maximize revenue or to minimize upstream traffic, etc. So yeah, the network operator changes this partition, continuously monitor what is the effect of these changes in some signal. It can be the upstream traffic, or it can be the revenues if we talk about pricing. And so here I'm explaining a bit the general, in general terms, what we have done in the last papers. And so we assume that network operator monitors these signals continuously, and based on this observation creates a model that relates the objective function to the different decisions it can take. And this model can be simple regression or Bayesian neural network. And then based on this model, the network operator can calculate a policy guiding how to optimally modify this allocation. And the loop continues. This is the general setting that we used. Then we use different methods and for different objectives: upstream traffic reduction or revenue maximization, Q-learning or hidden parameter Markov decision process. I will not go into the details, but they can be resumed in this picture here. So we call this approach data-driven optimization, because optimization decisions are based on data that we can measure and offset. And so here are some results to show that even if the network operator optimizes in the dark, still it can have good decisions and can take good decisions very fast. Here we are plotting the upstream traffic that we want to reduce. And here we are comparing different methods. Model-based reinforcement learning is the one that manages to reduce the upstream traffic, taking the good allocation partitions very fast. And it goes close to the optimal theoretical allocation very fast. So this is compatible with the dynamics of traffic. And not only we can have good performance and empirically, but we can also have some theoretical guarantees. So with this model, we are ensured to converge to the optimal theoretical allocation and stay there with probability 1. So even if we optimize in the dark, we have guarantees of optimalities in the long run. And here is another approach. This time the problem that we had was pricing. The network operator was pricing these resources. And here we verified if it was possible to transfer what we learned in a situation into another situation. So, and we used hidden parameter Markov chains. And the concept is that we can suppose that we are an operator, we want to deploy a new base station with an edge deployment there. And we want to have the appropriate pricing adapted to the number of users, to the coverage area, etc. We don't know anything about this new scenario, but we learned something in the previous scenario. So what we can do, what we did, is to imagine to train the model on previous observations and on synthetic data. Then put the agent in this new base station and take the first, let's say, 20 days to calibrate the model that we learned before to the new scenario. And then, starting from this point, learn a policy using Markov decision processes on the calibrated model. And what we see here, we are comparing our approach with classic model-free reinforcement learning in 3 different sets. And we see that with this approach, with this transfer of learning from previous scenarios to the new scenario, we can very fast increase revenues. So we can exploit what we learned before in the new scenario. Yes.
What is it on the vertical line? What is it?
Daily average value.
No, and the
Fictional update. I did not explain, but so when we have a model of the system, then we can compute the policy by running fake updates on the model, not on the real system. So we can make much more updates that we could do in the real system. In 1 second, we can make 1 million updates on the model, while in the real system, it would not be possible. And this is why we can accelerate the convergence to a good policy. So to recap, we believe the network operators are the key to edge computing because they are the only ones owning the resources very close to the users. And we believe that they have a lot of opportunities if they virtualize these resources and they open them to third-party service providers, not just using these resources for their own purposes. And we studied this scenario for different use cases. And we're studying the problem of how to allocate these resources using partitioning techniques or pricing signals to allocate based on the load, on the traffic load. And we explored the use of data-driven methods that consist always, even if with different variants, in interacting with the system, starting to take some decisions, observe how the performance changes based on phase out to our decision, learn the model based on these observations, and then learn a policy on top of a model. And it's all for me. And okay, yes.
I have a question. So
Yeah.
It's the same question I had before, but there is something here.
Yes.
And it's a question for all of you. So this was my understanding of things this morning before I came here. Now I have this question. If in the far edge I put the distributed unit and nothing more than the distributed unit, because it doesn't seem to me that it makes sense to have the central unit so close to the edge. I land in a situation where I have data in the distributed unit, but I cannot use the distributed unit because the scheduling of where to make my stream of the movie go is taken by the central unit. So maybe there is no.
This is the kind of feedback I would like to know, because our approach.
Because I
Right.
don't understand it. So.
Right, and to be honest, so we are not very precise in terms of architecture, which is not necessarily a bad thing, because if you just see the architecture now, you are stuck with what you can do now. If you say, okay, it would be nice and advantageous to do something different, then you can see if their current architecture is not appropriate, and why not? You can modify the architecture, and you can have incentives to move the central unit even into the base station. Why not? But you seemed not to agree with Francesca.
It really depends where you have your end connection point.
That's my question. My understanding. Can you have an end connection point before the central unit?
What do you mean before the central unit?
Like, my understanding is that the radio gives you the data, the does the.
And then they have to, it depends what you're
Give
talking
you-
about. If you want
gives
to
you
talk
a
IP,
bit
you need to go up to the point. If you need to talk IP, you need to go up to the point.
Okay.
That is the entry point.
unless you have a local breakout
Yeah.
for the user plane.
Yeah, but
Okay.
So maybe it's complicated to have this local breakout in the user plane.
Something that must be done on purpose, for example, for the web networks, they do that. They do that.
but for over the top services,
Over the top services,
unless you have.
in principle, it's possible.
In principle, it's
technically
possible.
but it's not a general solution. So it's something that is made on purpose for specific
But if you
service.
want to drive, like, so if you want to have the e-commerce service, you are
That
starting
case,
with the
you
public
need
network.
that. You need that, but at the moment there is no one.
Yeah.
But in principle, you need that.
And the fact that in the moment
And
there
you
is,
can deploy the-
Yeah, but you need to also terminate the UPF for the user plane only there,
Okay.
only for the specific services that can be filtered and sent to the local.
Okay, now it's here.
Okay.
So you,
That-
okay,
yes.
sorry.
so it's possible.
Important.
So the architecture gives the
That's
flex.
not very clear to me before
It's
today,
possible,
so, yeah.
but it's an architecture that at the moment is considered only for application networks.
Right, but it doesn't mean that it will never be considered
of
for
course.
multi-tenant
If they want to
cases.
sell the capacity,
Right.
that's the only way they have to go.
And they can sell, the network operator can sell this capacity as much as they want because they are the only ones going there. Google doesn't have the deployment of Orange. This is my vision, right? So Orange can say, okay, you want to run augmented reality or something like that. You have to go through my network and I can price you, I can charge you like a crazy and I will get a lot of money. So, but I don't know why they don't do so.
The trend is that they are the over the top that are
Right.
hosting the services of the operator. So they are already hosting the core network and they are ending to host also the CU and in certain deployments like the private network, they will be hosting also the DU.
Right,
So
The over the top, they're pushing the operators
right, but
to use their platform
Mhm.
in the infrastructure they are deploying.
but aren't
DH.
right,
Our view, it's the opposite.
right, because aren't network
It's a
operators
commercial fight at the moment.
by doing so, aren't network operators shoot at their foot? They are shooting at their foot, not exploiting the power they have. This is my vision, but I would like to have opinions from the network operator. Why are they giving out the key of applications to Google and Amazon? This I cannot understand.
The reason is, I mean, maybe Stefano can have better answer. But the reason is that
we are recorded.
You can stop. I'm so interested.
the point is that the operators don't have skills, first of all. First, I mean, and they are even cutting people, so they will lose skills just to be flat.
The skills of automating.
The skill, technical
Managing,
skills. They only have marketing people. They know how to make an advertising video to make a description. They don't know how to run the net.
Everything they can do, they
Yeah.
So yeah, sure.
Exactly. First thing. Second thing is the reason, one more technical, the one that I was mentioning before. So without the platform of a cloud provider, right? The functions, the Lambda functions, everything, all the components that you have, pre-cooked components that you cannot live without. So for programming on a platform like Amazon or Azure, it's impossible to develop anything. So which means that for this reason, the operators cannot make without the OTTs. But the OTTs can make without the operators.
Yeah.
So the weak part at the moment is the operators. Even if in principle you are right.
Yes.
This was the original idea of the Mac, mobile multi-access edge computing, right? In practice, the power they have is much less than they expect.
They chose to underpower themselves. Maybe it was too difficult for them, but
Suiciding. But
Yes,
that's what they
okay.
are doing. Yes.
Maybe they were so much cutting the expenses. Maybe they were trying to cut the expenses.
Yes.
There is a limit to that.
Yes.
But we believe that there will be
There
some
are
courageous.
in the world where this is not the case.
Oh.
China, for example,
Mm.
the operators are much more powerful than the OTTs. And they are deploying a lot of cloud computing, a lot, because they already have infrastructure and of course they get the money from the government in ways that we don't, right? In US, the operators are a little bit better in terms of economics than in Europe.
But even there, they are externalizing because, for example,
Exactly.
a recent announcements made few months ago that the AT&T has provided this one management system to Microsoft. And Microsoft has implemented it. So they will include also the management in the cloud.
Which means that the US can decide to get rid of the operators and put the network in the hands of the OTTs that are Americans. The problem is that in Europe we don't have these options. Right? That's the problem. And as and one more time, we are the weak part in this global fight. Europe.